Alright, so before starting the video, I'd like to tell you that in this channel I will be discussing various MCQs, important MCQs related to GATE, IAS, UPSC or all state PSCs, SSC. Okay, then also I will be discussing various concepts of all the subjects of mechanical engineering, and then there will be long numericals also, which will help you in cracking GATE, IAS, etc. exams. Okay, so go to the playlist, you will find all those contents in different playlists, and in this series, in this playlist, I am discussing about various MCQs. So starting with the thermodynamics subject, and in this first set, I will be discussing 10 questions, and along with it, I will discuss all the answers in detail, so that it will be able to answer all the related questions as well. Okay, so starting with it, the first question is here: which of the following is not a point function of the system? Temperature, pressure, specific volume, and heat. Okay. Point functions are all those properties, all those functions which can be defined by a point. So at a particular point on PV diagram or TS diagram or SS diagram, we can say that the value of this is this much. So for example, pressure, we can say definitely for using a point only, volume also, temperature also, specific volume also. Okay, so heat and work, okay, mainly heat and work are not point functions, because that depends upon the path followed. If path is different, then amount of heat and work done is different. The area under that path will give us the work. Okay, for heat and work, what happens? Suppose in PV diagram, suppose this is the work done, then this is the amount of work. Okay, so if this is the work done from this one, suppose point to 2 points, then this will be the area will give us the amount of work done. Okay, we cannot say that at point 1 this much work is there, at point 2 this much work is there, because if the path changes, the path is different, then the amount of work will also be different. So here the answer will be option 4, heat. Heat is not a point function. Okay, so moving on to next question. Consider the following statements for petrol engine. Okay, petrol engine, SI engine. Number 1, higher compression ratio will increase the detonation tendency. Superchargers are suitable for decreasing detonation, and compression ratio of petrol engine is less than the diesel engine. Alright. So we will go by the statement one by one. The first statement says that higher compression ratio will increase the detonation tendency. What is detonation? Detonation is a knocking, that is a sound created by unwanted ignition in the engine. Okay, inside the engine. So what happens in SI engine? Because SI engine we have spark plug. Okay, spark plug is there, and because of the spark plug, what happens? Spark is generated and the flame propagates through the fuel and air mixer. Okay, the flame propagates uniformly burning the fuel and air mixer. But in some cases, what happens? Because of high pressure, high compression ratio, if the compression ratio is high, temperature, pressure is high inside the SI engine, inside the petrol engine, what happens? Before the flame reaches at some point, if here suppose the temperature pressure is very high, before the flame reaches, there is auto ignition will occur, and because of it there will be some sound. It is like rock, striking the walls of the cylinder, and those sounds, that phenomenon is called knocking or detonation. Okay, because of pre-ignition at some unwanted place before the flame reaches that zone of the cylinder. Okay, so what happens and then there is a difference between knocking in case of SI and diesel engine also. Suppose this is your TDC BDC diagram, and this is P, this is stroke length. So what happens in case of SI engine? In case of SI engine, the knocking occurs after combustion, after ignition. Okay, after the spark has ignited, then knocking occurs. Okay, that's why if the compression ratio is more, if the temperature pressure is more, then the tendency of occurrence of knocking in case of petrol engine is more. But that is opposite in case of diesel engine. In case of diesel engine, knocking occurs before the ignition, somewhere over here. This period is called ignition delay period. Okay, in case of diesel engine or CI engine, the knocking occurs over here before the ignition, that in the ignition delay period. So in case of diesel engine, we try to reduce the ignition delay period. This delay period is reduced so to decrease the tendency of knocking. Okay, so in that case we have to increase the compression ratio, pressure, temperature, etc. to minimize the chance of knocking in case of diesel engine. But in case of petrol engine, it is opposite. In case of petrol engine, if the compression ratio is high, pressure, temperature is high, then chance of occurrence of knocking is more. So that's why the first statement, it says the higher compression ratio will increase the detonation tendency. That is correct in case of petrol engine. In the question it is said that we are talking about petrol engine, so the first statement is correct. Second, the superchargers are suitable for decreasing the detonation of petrol engine. Now what is a supercharger? Supercharger are those devices which compresses air that is coming to the engine, coming to the cylinder. Okay, before entering the cylinder, the air is compressed to a higher pressure. So if the air is compressed, then what will happen? The compression ratio is more, the pressure will be more. The pressure is obviously will be more because of the supercharging. And as I told you, in case of petrol engine, if pressure is more, then chance of occurrence of knocking is also more. So the second statement here is not correct. Okay, the second statement here is not correct because supercharging will increase pressure and that will also increase the tendency of knocking or detonation. Okay, the second statement is wrong. Third statement says that the compression ratio of petrol engine is less than diesel engine. So what happens in diesel engine? Diesel engine is CI engine, compression ignition engine. So the diesel is burned by compressing it. Okay, compressing it. And in case of petrol engine, we have spark plug. So since in case of diesel engine, compression is the only reason for burning the fuel, that's why the compression ratio is always should be higher compared to petrol engine. The compression ratio in case of diesel engine is always high, in the range of 16-20. Okay, whereas in case of petrol it is around 8-12. So in case of diesel engine, the compression ratio is high, and the third statement here is also correct. So here the correct statements are 1 and 3. The second point is not correct. Okay, moving on to next question. Which one of the following is the correct combination of type of thermometer and the thermometric property respectively? Alright, so thermometric property is the property of the measuring device which helps us in finding the temperature. Okay, we cannot directly measure temperature. There is an intermediate property of the system which is measuring the temperature, with the help of which we have to find out the temperature. In case of thermistor here, thermistor actually works on resistance. We know that the heat is generated when current passes through it. I square R is the amount of heat generated. So that if the resistance is more, it will be more. So that on that principle the thermistor works. So voltage is not correct here. Thermocouple. Thermocouple is a device which works on Seebeck effect. So what is a Seebeck effect? If we have joint of two dissimilar metals, and if both the joints are at two different temperature, then what will happen? Between those two junctions there will be EMF generated, and that EMF will be proportional to the temperature. Okay, so if we can measure the EMF, then calculating it we can find out the temperature as well. Okay, in the thermocouple it is already calibrated for how much EMF sense, what is the temperature difference. If we know the temperature of one junction, then we can find out the unknown point from the unknown point. Okay, so this is correct here. The number 2, thermocouple and voltage, is correct. Mercury thermometer, we know that what is the thermometric property? It is the level of mercury, the height of mercury. That is the thermometric property in case of mercury thermometer. So that is not correct, and obviously 4 is not correct. So correct answer here will be number 2. Moving on to next question. If Carnot engine rejects 1/4 of the heat from the reservoir, what is the efficiency of Carnot engine? 0.25, 0.5, 0.75, 0.8. So the rejected heat is 1/4 of the heat absorbed by the engine. Okay, so what happens in case of Carnot engine? Heat is taken from one reservoir and heat is rejected in another reservoir. Suppose this is Q1, this is Q2, and work is done here, and the efficiency of the engine is given by 1 minus Q2 by Q1. Or if T1 is the temperature here, T2 is the temperature here, also we can write 1 minus T2 by T1. Now in the question it says that the rejected heat is 1 by 4th of the heat taken. Okay, so Q2 is Q1 by 4. So 1 minus Q1 by 4 into Q1 get cancelled out. 1 minus 1 by 4, which will be equal to 0.75, or 75% will be the answer in this case. The correct option here will be 0.3. Option 3 is the correct. So moving on to the next question. Consider the following statements. Property is a path function. Properties are exact differential. Density is an intensive property. Which of the following statements are correct? Okay. So statement 1. Statement 1 says that property is a path function. Properties are not path function. Properties are point functions. What are properties? Properties are like pressure, temperature, etc., which defines a state of any system. A state of any liquid or any gas is defined by properties, and those properties are, for example, pressure, temperature, volume, specific volume, etc., and those can be defined by a point. Okay, that does not depend upon the path followed. Okay, so the first statement is here is wrong. Properties are point functions. Second is properties are exact differential. Yes, they are exact differential. What are exact differentials? If we can write dP as P2 minus P1, then this is called exact differential. Okay, the differences gives the difference. But in case of heat or work, we cannot write Q2 minus Q1. This is not correct. This is inexact differential. The path functions are inexact differential and point functions are exact differential. Last one is density is the intensive property. Intensive properties are those properties which are independent of mass. IN for independent, IN for intensive. Okay. Density, what happens? Density, though the formula is density equal to m by v, but consider any mass or any volume. What happens? If we take some part from here, some part from here of defined masses, what will happen? The density will be same. Okay, whether we take 1 kg, whether we take 2 kg, 3 kg, the density will be same. The density will not depend upon the mass. Okay, so that's why density is an intensive property, not an extensive property. Volume is extensive property because volume, when mass increases, the volume will also increase. Okay, but densities will not depend upon mass. If the body is homogeneous and the density is same throughout the body, then density can be said to be density is a intensive property. Okay, so moving on to the next question. 1 kilojoule of heat is transferred to the surrounding from a reservoir at a temperature of 527 degrees centigrade. The change in entropy. Okay, options are given: minus 0.8, plus 0.8, minus 1.25, 1.25 joule per Kelvin. Now, what is happening here? Heat is transferred to the surroundings. Okay, heat when comes into the system, that is taken as positive heat. When heat goes out of the system, that heat is taken to be negative heat. So here we have to use a negative sign, and the formula for entropy is given by dq by t. Change in entropy, ds is given by dq by t, and since here heat is going out, so it will be minus, how much is the value? Minus 1 kilojoule or 1000 joule, since the unit in answers are joule in joule, so we are adding 1000 divided by 527, that will be in Kelvin scale. 527 plus 273 will be equal to 800. Okay, so minus 1.25 joule per Kelvin is the answer. Okay, so the third option here is the correct option. Okay, what is entropy? Entropy is the measurement of unavailable energy. Okay, So while defining first law, we say that energy cannot be created or destroyed, it can be changed from one form to another. But whenever we change the energy, whenever we do energy interaction, especially heat, what happens? The available energy decreases, because heat is a low grade energy and it cannot be completely converted into work. Some amount of heat always lost to the surrounding, okay? That means the available energy decreases each time we interact heat. Alright, heat is transferred from one system to another, then the available energy is decreased and entropy increases. Entropy is the measurement of unavailable energy. The more energy becomes unavailable, the more entropy increases. Okay. Next is, if 1 kg mixture of steam contains 0.8 kg of dry vapor and 0.2 kg of moisture, then the dryness fraction of the steam is given by, what is dryness fraction of steam? Dryness fraction of steam is given by mb by mb plus ml. Dryness fraction is denoted by small x, is given by mass of vapor divided by mass of vapor plus mass of liquid in the system. Okay, in TS diagram, inside the vapor dome, this is L plus S, liquid plus steam. This is steam, this is liquid, this is why this steam. Okay, so inside this, the mass of this ratio is used to define the quality of steam. The more the value of x, more the quality will be good. Okay, quality is said to be better if the value of x is more. X will be very form, here it will be 0, it will be 1 here. Okay, because here mb will be 0, here ml will be 0. Okay, so in this case it said that if there is 0.8 kg of dry steam, dry vapor, and 0.2 kg of moisture, then what will be the value of dryness fraction? Obviously it will be 0.8 because it is the measure of dryness fraction is measure of vapor. 0.8 by 0.8 plus 0.2 will be equal to 0.8. Plus 0.8 plus 0.2 equal to 1. Next question. Entropy change depends upon heat transfer. The correct answer is heat transfer, because ds is equal to dq by t. Already we discussed that depends upon the heat transfer. So correct option here is heat transfer. Among the following options, which one is correct? Entropy signifies available energy. According to second law, energy can only be distracted. For a process to be isentropic, it must always be adiabatic. None of the above. Okay. The first statement, as I told you, energy signifies unavailable energy, not available energy. So first option is ruled out. Okay, it is not correct. Second says that not only about second, energy cannot be distracted is a wrong statement, because energy can be transferred from one point to another. It is changes its form, but it cannot be distracted. And second law does not say this. Second law, there are two statements of second law, Kevin Planck and Clausius. Clausius says that from a cold body to a hot body, we cannot transfer heat if we do not apply any extensive work into the process. And Kevin Planck's statement says that we cannot produce work by exchanging heat with only one thermal reservoir. There must be a source, there must be a sink. Okay, all the heat cannot be converted into work, that means. So that is also not correct. 3. For a process to be isentropic, it must be adiabatic. No, that is also not correct, because it is not only adiabatic, it should be reversible adiabatic. Not all adiabatic processes are isentropic processes, but all reversible adiabatic processes are isentropic processes. Okay, because isentropic means what? Isentropic means ds is 0. If there is it's isentropic, the ds is 0. So for ds is to be 0, we know that ds is equal to dq by t. So here ds will be 0 if dq equal to 0. Now what is when dq is 0? dq is 0 when the process is adiabatic, when there is no heat transfer with the surroundings. So dq is 0 in case of adiabatic process. But this statement, this here, ds equal to dq by t, is only valid for reversible process. Okay? Only valid for reversible process. This not ds is not equal to dq by t in case of reversible or irreversible process. So this to be true, this to be ds to be true, the process must be reversible adiabatic process. So here the correct answer will be option number 4, none of these. In a closed system, volume changes from 1 meter cube to 2 meter cube and heat addition is 2000 kilojoule. The change in internal energy given the pressure volume relationship is P equal to 1000 V kilopascal, where V is volume in meter cube. 500, 1500, 3500, 4500. Okay. So it says that the volume changes from 1 meter cube to 2 meter cube. The relationship between pressure and volume is given this, and we have to find out the change in internal energy. Q is also given. So for that, first we need to find out the PdV work done. Okay, if we write dq equal to du plus PdV, that will give us the amount of work for PdV volume change. Okay, dV volume change. But here we are talking about the whole process. That's why we have to use integration, and it will be Q equal to U plus integration of PdV. And since it is given that P equal to 1000 V, so here we can put integration V1 to V2 instead of P value 1000 V dV, which will be equal to 1000 V square by 2, and our volume is going from 1 to 2 meter cube. Okay, so it will come out as 1500. Okay, 1500, the unit will be here kilojoule. Okay, so 1500 kilojoule. So it means our PdV work done here is 1500. This is 1500. Q is given as 2000. So U will be equal to 500. So the answer is 500 kilojoule. The correct option is option 1. Okay. So in this video I have discussed these 10 questions and along with all the facts which will help you in solving the related problems, numericals and questions as well. In the next set of videos, MCQ questions, I will be discussing more questions on thermodynamics, then on the other subjects as well. And related to this, all these theories that I discussed, that those are separately I have discussed in the concept playlist. So please go through them also. That will help you in solving this type of problems. Okay, thank you.